Hello, everyone, and welcome to this overview of Agile modeling, a set of modeling principles that I hope will help you as a software engineer in an Agile world. At its heart, modeling is about creating an outline of an activity to help us plan ahead. As Pressman explains in Software Engineering, a Practitioner's Approach, it is natural to create rough sketches or outlines of the things we want to build before we build them. In the specific case of software, we often need an abstract representation of the system that shows what user features we must create, how real-world objects will be represented via classes and methods, how data will be stored, and so on. Regardless of the form of the representation, this is the gist of what a model is, an abstraction that guides what we do. This abstraction allows us to plan ahead, see potential obstacles, and understand user requirements. This makes modeling a natural third stage in the Pressman process framework after planning and before coding. But as soon as I said the words requirements and planning, alarm bells might have rang for those that believe in agility. As Robert Martin reminds us in his Agile principles, software requirements change, often and without warning. And when requirements change, the software must change, which means the models of the software become obsolete, or worse, deceiving. Imagine spending hours creating a very detailed model of a hotel booking website. You start coding based on the model, but suddenly the hotel wants the website to show a targeted advertisement for nearby restaurants and businesses. Not only have we invested time in the model, we must now reinvest that time to add an entirely new feature suite. This leads to the big question: can modeling still help software engineers that want to be agile? Take a moment to think about what you know about modeling and what aspects of it might need to be modified to make it compatible with modern agile development. In 2002, Scott Ambler, a prominent software engineer, provided his answer to this question, and his answer was yes. Modeling can still be very useful, but we must think of modeling in agile terms, and we must make it a coherent part of agile software development rather than a standalone process that must be done for its own sake. To make that happen, we must first understand and embrace the principles of agile modeling. First, we must model with a purpose. This means that a model should help a specific person do a specific task using your model, i.e., to write code or understand a requirement. If you do not know who will use the model to accomplish what task, do not create it. Second, travel light. This means creating models and documentation only when they become absolutely necessary. Do not create models of systems the user has not yet requested. Do not create models people don't need to do their jobs. Third, embrace multiple modeling techniques. For example, you do not have to use UML state diagrams for every part of the system, or solely because UML was used for a different part of the system earlier in the project. Embrace whatever tools work in different contexts and learn different tools so you can be more agile. Fourth, keep models as simple as possible. Do not add features to your objects until you know what those features will be. Do not create classes that don't represent known user requirements. In short, do not make assumptions that add complexity to the models. The next 7 principles are all about mentality and directly reflect Robert Martin's Agile principles. Focus on delivering working software and maximizing stakeholder value. Every part of software engineering is ultimately aimed at those goals. Embrace change and make your models adaptable to change, not resistant to it. And always deliver high quality work, not merely a lot of work. A small, understandable model that leads to working code is better than a detailed but confusing model that no one can understand. Remembering these general principles of agility when modeling is important to avoiding the pitfalls of doing too much or unnecessary modeling. Now, take a moment and consider how these last 7 principles compare to the broader Agile Manifesto. But while all these principles are sound, what can we learn from Agile modeling to improve specific workflows in our day-to-day jobs? Next, we will discuss 2 specific areas: Agile data modeling and Agile requirements modeling. Agile data modeling usually begins with transforming user stories into an initial domain model, a high-level conceptual map of the objects and classes of objects that represent the user's requirements. This initial domain model should be very sparse. Do not create classes or objects that do not explicitly represent something in the user stories. Do not add attributes or methods to the classes yet. Consider creating the model on a whiteboard where everyone can see it. Allowing people to see the model at all times is a healthy way to create more feedback. Next, start adding methods and attributes to the model that represent specific items in a user story. Do this in a separate physical model, and only to the parts of the model that user stories can directly inform. It is crucial to create code soon after or in parallel to this step. Do not go off and create a detailed data model without coding. At this point, you may be looking for recommendations on the right language, tool, or format to use for the data models. But Agile modeling suggests you simply pick the right tool for the job. Whether it's UML on a whiteboard or a design language your own company has created, the important thing is for the people using the model to understand it and for it to represent the system accurately. The key takeaways here are simple. Do not make assumptions about what will need to be added to your data models in the future. Make your models as visible and open to others as possible, and do not add things to the models without coding new additions soon thereafter. To maximize the effectiveness of our data models, however, we must have clear user requirements. So here we will discuss Agile modeling of requirements. There is one overriding suggestion that Scott Ambler makes on this topic. The customer is the only legitimate source of requirements, so you must communicate clearly and model only what the customer communicates. You should never find yourself modeling requirements that you assume a user needs, or making guesses about what a requirement means. Do not model your own assumptions. If you're not clear about something, stop modeling and go back to the user. Agile modeling suggests that requirements modeling should be done in person, preferably on a whiteboard, so that the user can see the model or any other artifacts you generate during the session. It is also best to keep requirement modeling sessions short, i.e., 30 minutes or less, and have them more often, rather than relying on one long session. Each session should have what Ambler calls just barely enough participants. This means that every participant should be a real stakeholder in the project and should have something functional to contribute to the meeting. Most importantly, sessions themselves should be agile. That means that you should not constrain the session discussions based on what your models need or what your models can handle. For example, if you don't know how to represent a user requirement with the modeling tool you've chosen, don't stop the discussion. If needed, pivot to a different tool. Hint, this is why it's so important to be familiar with multiple modeling tools. Tailor the tools you use and how you run the meetings based on the users themselves. If a user is a technical expert and has detailed ideas about how to implement a requirement correctly, don't shut that down just because it doesn't fit on the index cards you brought. Recalibrate the tools instead. The artifacts generated during and after requirement sessions should also follow agility principles. This slide shows a few of the requirement gathering artifacts that are useful in agile modeling, but none of these are mandatory. As always, you should lean on whatever allows the user to communicate clearly and allows you to write good code later. The more of these tools you're comfortable using, the better you'll be. The one exception are acceptance tests, which should be produced in almost all projects. Testing is crucial to the Agile philosophy, and good acceptance tests are the best way to ensure user requirements are met. Ultimately, Agile modeling is exactly what the name suggests, bringing agility into the modeling process. If you can do that by being flexible in the tools you use, creating only what you need, and avoiding unnecessary complexity, modeling becomes a powerful ally. It will help you and your team maintain a good, shared understanding of the system, visualize the work ahead, plan Scrum sprints, and understand requirements without burdening you with useless work. So, if you're interested in learning more, I advise you to visit the Agile Modeling website and become an Agile modeler yourself. Thank you for your time, and good luck.